Good evening, class. Welcome to my classroom. I am Reshma C., Assistant Professor, Department of Civil Engineering, SNIT, Adur. My subject is CE 202 Structural Analysis 1. In today's class, we are going to discuss some of the previous year university questions of KTU from 6th module. Sixth module is all about arches, its different types, mainly three-hinged parabolic or circular arches, then the Eddy's theorem, analysis of three-hinged arches, then equations to find out support reactions, normal thrust, radial shear at any section on the parabolic and segmental arch, then some simple numericals based on this, and moving loads on three-hinged arches. Moving on to the first question. Justify that an arch is more economical compared to simply supported beam of same span carrying the same load. This question was asked during May 2017 for 6 marks. If such a question is asked, you have to write on the basis of bending moment. That is, the bending moment for a simply supported beam at any section XX, mx will be VA into x. Likewise, bending moment for an arch at any section xs will be mx minus hy. That is, bending moment of an arch is reduced by a considerable amount due to the horizontal thrust. So if we compare, we can see that the arch has a reduced moment, which means that it can have a reduced cross section, which again means that an arch is more economical. Moving on to the second question. A three-hinged parabolic arch has a span of 18 meter and rise of 6 meter. The arch is hinged at the springing A and B and at the crown C. It carries a UDL of 20 kN per meter over the left half of the span and a point load of 100 kN at 4.5 meter from the right support B. Find the bending moment, normal thrust and radial shear at a section 3 meter from the left end. In this question, first you have to find out the support reactions using equilibrium equation. Then you have to write down the equation for parabola. Then you have to find out the value of theta at 3 meter distance from the left end. There you have to cut a section and find out the bending moment using equation mx minus hy. Then you will have to find out Vx and Hx and apply it to the equations of normal thrust and radial shear. A three-hinged semicircular arch of radius r carries a UDL of W per unit run over the whole span. Find horizontal thrust at each support and location and magnitude of the maximum bending moment. This question was asked during December 2019 for 10 marks. In this question, you can find out the support reactions using equilibrium condition and horizontal thrust by taking moment about a hinge. And you can get the maximum value of bending moment by differentiating the equation for bending moment and equating it to 0. You will get the position where bending moment will be maximum. Fourth question is to explain with the help of sketches the different types of arches. It was asked during May 2019 for 8 marks. In this, you will have to describe the different types of arches based on their shape, their geometry, their number of hinges, etc. You have to define each types and draw a neat sketch representing each type. Sixth question is a parabolic three-hinged arch carries a UDL of 30 kN per meter on the left half of the span. It has a span of 16 meter and a central rise of 3 meter. Determine the resultant reactions at the supports. Find the bending moment, normal thrust and radial shear at a section 2 meter from the left support. It was asked during May 2019 for 15 marks. In this, you can find out the resultant reactions only after finding out the support reactions VA and VB as well as the horizontal thrust. To find out a bending moment, you will have to cut the section at 2 meter distance from the left support and write down the equation mx minus hy. To get the normal thrust and radial shear at that section, we will have to find out Vx and Hx and substitute these two to the equations of N and F. Now the last question is to state Eddy's theorem. It was asked during May 2019 for 5 marks. In this you will have to state what Eddy's theorem is, as well as you will have to represent it with a neat sketch. Even if the same question is asked for more marks, you will have to write down the proof as well. Sometimes it may not be directly specified in the question to write down the proof, but you will have to understand it from the marks. Thank you.